please ask questions straight away so we can try and answer things as we're going. So we've got the AMPT machine. There's also, in the early days, was an SPT, Simple Performance Testing Machine. Then they changed the name to the AMPT, which was the Asphalt Mixture Performance Tester. So some people might refer to the machine as SPT, others will be AMPT, so it's the same meaning. So this machine was designed, set up for the NCHRP 9-29 development work in the early 2000s. I think there's now the 2P79 has taken sort of this the main test procedure for this, testing super pave sort of asphalt mixes. The machine for this one, the size of the sample is 100 by 150. You can also, we have a UTM25 machine, which is a more universal machine, which gives you different types of testing abilities. This machine only allows for the dynamic modular test 3 on-specimen transducers. In a UTM25, if you want to do different research or other type of testing, you can put 2, 3, 4 LVDTs depending on what hardware transducers you have. So this machine was sort of built as a single sort of standalone package, which is easy for just routine operators to do the testing. The UTM25 is more for research people who want to do different things. So you might have some different testing, you can use this machine. This has a number of different jigs. You can see there's a triaxial cell, universal triaxial cell for unbound granular material, or if you want to do confined testing on asphalt.
This one you have to put inside?
This one goes into here. So we can adjust the height of the chamber crosshead and that can fit in. And then we also have different jigs for indirect tensile type testing. So this machine is much more flexible. And this one, this is our main control unit, we call the IMAX. That's an integrated control system.
Can I ask you? So you need to say that the one that it can do, this one can do also.
Yes, and this can do more.
Can do more.
Yes. So this is more designed for specific type testing. You can do different things on this. So there's a few of the newer things the Americans are doing is tension testing in the AMPT, so we can supply jigs and arms on there where you can do some tension testing on the samples.
So that is accessory?
Yes.
And you do not have right now?
No, if there's a ring up the top normally where you can put in a platen which you glue to the sample so you can do tension type testing. I think it's the uniaxial fatigue, I think SVECD test. Are you familiar with? Yes. Some of those protocols. So there's a few development test methods at the moment going through the ASTM system. So this one.
Sample conditioning, you cannot do, you have to do it somewhere else and then transfer the sample.
These ones,
testing.
you can.
No, for this one, and not for this one.
You can, because it's a very small chamber, you can condition one sample in the machine, but ideally if you have an oven close by somewhere for conditioning, bring the sample.
So not like this one where you can condition.
Yes, you can put many samples in these machines. And in the test protocol, it originally said that from getting your sample out of conditioning into the machine and ready for a test, you had to do it within 30 seconds. So we had to come up with quite a quick method of getting the sample ready. So we had quite small chambers, so then get the one sample, we can automatically raise it, lower it, and then you can get the temperature back up with minimal disturbance on the sample. So inside this machine has one of these controllers and also one of the hydraulic power pumps here. So all that is inside this unit. So again, you can see how easy this one is to position, set up in the lab, where this machine needs quite a bit of room and space to operate. The software we run is called UTS, so Universal Testing Software. It's written in the Delphi programming language, a high-level language. Runs on Windows operating system. At the moment, was geared for Windows XP and Windows 8 and 7 coming out now. Windows 8, we're still getting some development going there, different drivers to operate the system. But the PCs here are all, I think, Windows 7 machines, so they all run. Okay. Normally we'll provide a PC with the equipment, we set the software up, make sure it all works back at IPC in Australia. So it's very easy to just come on, turn the machine on and run it. So for this system, you typically need some air for the confining pressure for raising the cell. At the moment, there's no, it was meant to be a compressor set up for the lab here. We've got this small compressor we can use for testing. It's sufficient to run an AMPT because in the confining tests, if you're doing any confining pressure tests, the specification only, I think, is a maximum of 210 kPa cell pressure. So it's not very high pressures, whereas if you're using the UTM25 with a universal triaxial cell, you can go up to pressures of 1000 kPa depending on your air supply. These devices are rated up to 1500 kPa. So again, this is, if you want to do high confining pressure type testing, you need a UTM25. But for this machine, depending on the standard was only in certain pressure conditions and temperature ranges. So this was built around the specification. So we have a temperature controller on here which can go from 4 to 60 degrees. So depending on the test protocol, I'm not sure if you're going to be using in the colder temperatures here, temperature range, or just from 20 degrees up to 55 degrees. So it'll depend on how, which methods and tests you're going to do. So these, we have some LVDTs. They're nice and easy colour coded. So you can see inside the chamber with different colours. So this is a 1mm span transducer. And for the dynamic modulus testing, you can put them onto the sample. And for the flow number, flow time testing, they just use the actuator and a load cell to conduct those tests because they're really just interested in the flow point, the flow time or flow number. And with dynamic modulus, you want more accurate readings. If you're measuring on the actuator, you also get compliance in the machine, so any slight bending in the frame, although minor, could be quite significant in your sample's modulus. So they usually measure on the sample. So before we were just setting up a...
The temperature range.
Okay, yeah, the temperature is from 4 degrees to 60 degrees.
Because if people then, the people who do dynamic modulus testing from -5, what do they go for UTM25?
Yeah, they would use a UTM25. So I think there has been talk of changing the temperature ranges in the test method, but I think originally they had from 4 to 60. I think they even wanted to go higher up to 75 degrees. So at the moment, this is just set for 4 to 60. So,
the problem is with the capacity of the compressor, it doesn't go down to something.
Yeah. And also, you need to be in an environmental room. Here we have nice air conditioning. In some places, they have this machine running in a room which is 30, 40 degrees, and they're trying to get down to 5 or 0 degrees. You just can't get down because you can't cool it because of the ambient temperature around. But having a cool lab like this, there should be no problem getting the temperature. I think the thing you could put in lower than 4 degrees and it'll try and get to that temperature, but the specification doesn't sort of... If you were to go to higher ranges, like with -5 degrees, you'd need larger compressors, refrigerators and things. So again, the cost will go up for those type of machines. But these ones here, I'm not sure temperature range. This cabinet was set to. We do have a number of different ranges of environmental chambers. I think the TSTR type testing, you know, you go down to minus 40 degrees, and some people even, you know, liquid nitrogen to get those colder temperatures. But these are just standard environmental chambers.
Is there any way to condition the sample outside, test it at higher temperature?
I guess if you put this to the maximum and the sample was quite warm, if you did the test quick enough, you could probably get sort of the high temperature. But I guess it would cool quite quickly, wouldn't it?
Yeah.
So this device here is how we attach the samples on. Before we were getting ready this morning, we were setting up preparing a sample. So we just have any type of epoxy glue. If you're working in high temperature ranges, you need a glue which will hold onto the sample. If you've just got a low temperature glue, the sample may fall off before you've even started your test. So we mixed up 2-part epoxy. So what here, we can attach our targets to this device. We apply glue to one end of the target, some glue onto the sample, and by closing this, it makes contacts, holds on for, depending on the glue, this one's 30 minutes for bonding strength, and then we can release and the samples ready. I guess it can go back into the oven and be ready for your testing. So usually there's a kit which comes with the AMPT, has the accessories. Usually there's a pack of 24 targets, so there's six targets a sample. So you can prepare quite a number of samples with the targets and put them into the oven for curing and for conditioning. So these are.
Then that clips we can reuse, right? Again.
Yeah. Once you're finished, you can clean them up. I guess put it into the oven as well, heat them up, then clean them off.
And then
Yeah, and reuse them. So that's just getting the sample ready. Then we've also got these little what we call X-Men. There's a little hex pattern in there which matches the pattern on the sample. So that can just go onto the sample. So we have 6 of those, and then our displacement transducer can fit in between. If you're doing just the flow time or flow number test, you don't need the targets because it does not use those transducers. So you can just grab the sample straight out of the oven, conditioning, put it in the machine, and run your test. So the dynamic modulus test goes from 25 Hz up to 0.01 Hz frequency range. The current, I think, TP79 does not use all those temperature ranges, frequency ranges. I think there's 3 frequencies. I think 10 Hz, 10, 1 and 0.1.
No, we have over 5 or 6 frequencies.
Okay, but I do have some copies of those methods here. We can get some later and we can go through them. So the software is selectable, so you don't have to do all those frequency ranges. You can select the ones you require. So if you're doing the fast frequencies, the test, it only applies 20 cycles in dynamic modules per frequency. So at the slowest frequency, 0.01, it's 100 seconds for one cycle. So if you multiply that by 20, you've got about 20-30 minutes of a test at slow frequency. So it's a very quick test. The flow number, flow time test goes for, I think, 10 or 20,000 cycles with a 0.1 pulse, then a 0.9 rest, 0.1 pulse, 0.9 rest. So that may take 2 or 3 hours to run one of those tests. So here with 2 machines, you could easily run 2 types of dynamic modulus and flow number tests together. So you can do your testing a lot quicker. So on this machine, if we solve it first. So But typically, when you're going to first of all start this machine in the morning, you know, turn your PC on. We've got the main power points up here, so the PC and monitor are separate fuse points. So you turn your PC on, turn this on, so you'll see the light, and you'll also hear the machine starting up. This is an emergency stop button, so normally if it's pressed in, it isolates the external air pressure. So if for some reason something fails and the full pressure from the air supply tries to come into the system, that will stop it and lock it. The same thing, if the power goes off, there's a solenoid in there which will lock out the air supply. So you shouldn't damage your sample if something happens. So when we get to the software later, you'll see if this is activated, pushed in, you can't run the test because it disables some of the functions. So
this one will be pushed inside.
it's always pushed out when when it's
That's all.
open. Yeah. So it's closed. Yeah. Closes in. To open it, you turn it, and it pops out.
So which conditions would be for the testing time?
When you're testing, it's always out.
Same open.
So if you try
Same
it,
like that or
no, open. So if you try it,
yeah.
so,
Try.
so turn it.
Then,
So you open again.
Now this condition.
You don't go. So when you're running the test, it should be open.
Yeah. It should be open.
And then here we have the temperature controller. So we can turn on the controller. And there's also a cooler button, so we just turn that on. It has a little power up sequence. This controller is just a general purpose temperature controller. You'll see on many different types of machines. You have the top is the current temperature. The bottom value is the set point or target temperature.
This is by Celsius, right?
Yes, in Celsius. So to change the different temperature settings,
Yeah, here.
there's a number of buttons here.
Yeah.
This first button here activates the set point controller.
Okay.
So you'll see one is highlighted. So to move around, you press this button.
That the finger will be moved.
Yeah, and then you have up, down
Yeah.
here. So if we
We can increase and
reduce,
decrease.
so if we
Yeah. 3.
reduce here, and go to 32, and then press enter.
Is the temperature of the chamber?
Chamber will
So you'll see inside the chamber there's some 2 ports here.
Yeah.
So as the system is
Circle the air.
circulating the air, it's blowing warm air into the chamber.
So how much temperature should be?
So at the moment we've set this to go to 32 degrees.
And this one should be 20?
So this will increase. So this is the actual temperature.
Is actual temperature.
So inside,
the third day.
so if you look inside the chamber, you'll see there's a temperature probe behind the sample. So maybe come around and have a look. So see the temperature probe?
Yes, this line.
See the behind
Steel rod.
Okay.
the steel rod.
So from there you can read the temperature.
Well, that's the sensor and the software,
sensor.
and also on the controller.
Kasi akala ko lagi ka tinatawag niya. Kasi measure, yung
So the
pala
moment
machine
is
pala.
going to,
Now it will be increase the temperature.
yes. So this should go up to 32.
32.
So if we
The
go-
testing surface focus should be 32 the temperature.
depending on the test method, do you know what the temperature range is? The typical.
Usually, the standard is from -4, then 54.4 or -54. But this one, not doing the -4 degrees C, you start from 4 degrees C, then 54.
Oh, okay.
4 to 54, right?
And is there a room temperature setting too, or? But you have the freedom to do any temperature range you wish. So.
Yung sample, paano pagpasok doon sa loob?
I think I have somewhere.
Oo nga. Paano, dapat i-demonstrate niya rin.
If not, we can print some off.
Ayan.
Yeah.
Yeah.
Or if you have a separate oven, you can condition the samples. And if you want to do the cooler temperature ranges, it may take a few hours to get the temperature down to the cool. So, ideally, maybe the night before, if you're going to go to 4 degrees, set the controller to 4 degrees. The next morning, it's all ready, and you can do your testing. Otherwise, if you're trying to cool it in the morning, you might lose some hours of where you could be doing testing. So we can just let that go up. So yeah, we can use this sample, we'll put that sample in. So with our software, there's a number of different tests we have called the UTS. So we have up to over 40 different UTS tests available for different types of test standards. For the AMPT, we have UTS 006, which is a dynamic modulus test, and UTS 005, which is the flow number, flow time test. So the two different types of testing. Once you've used one sort of test, the look and feel of the displays and that is very similar. So it's not that difficult to understand a new test or a different test. Once you know sort of the way the system operates. So this device here is what we call our virtual pendant. It's a way of controlling the hydraulics of the machine. So that will be on the UTM 25. There's a 4-point bending apparatus there.